Hello Geometry. Today we're going to do 10.6 segment lengths in circles. So this is segment lengths, not angles, so we're not worried about the angles right now. We're talking about how long these lines actually are. And there's new rules, and these rules are not straightforward, so let's pay attention, okay? So first rule is the two chords that intersect, its pieces are going to be proportional. And that's a theorem. It's called the segment lengths of chords theorem, I believe. And I could spend time proving it, but I think it'd be more easier just to tell you what the equation is. So the equation is these two pieces, the product of these two pieces of the same line. So product, and remember products times. So product of AE times CE, so this line and this line, is going to equal the product of the two lines over here, DE, BE. DE times BE. Now this is multiplying, not adding. So what does that mean? The length of AC might not be equal to the length of DB, but it'll be 100% that the multiples or the products of these will be equal. So let me put an example. Let's see. Okay, this is a basic one. 3, 4, 6, x. Okay? So what do I mean? So let's set it up. This length times this length. So 4 times 6. The parts of the same line are going to be multiplied. Times this parts of the same line. 3 times x. 4 times 6 is 24. Equals 3x. X is going to equal 8. So this is going to be 8. And then we know, like I said, the distance are not necessarily going to be the same. So it's not going to be AC, the whole line is 10. BD, the whole line is 11. That's okay. But 3 times 8 is 24. 4 times 6 is 24. That's equal, and that's what matters. So we're not adding them, we're multiplying them, okay? So it's proportional to each other. So that's our first rule. Two chords in the same circle are going to be segmented. When segmented, I mean like cut into pieces, proportionally, okay? So that's our first rule. All right, we're going to our next one, rule 2. This is the segments of secant theorem, okay? Last one was chords. These are secants. Remember, secants they go in and out of the circle and hit the circle twice. So this is the rule. The proportions here is a little bit different. Is this small piece, so BE, times the whole piece, which is AE. Once again, small piece, BE, versus the whole piece. When we did the chords, it was the two pieces. Here is the small piece, or particularly, not maybe the small piece, I should say, the outside piece to the whole piece. Outside piece to the whole piece. When we do secants, it's outside to whole, compared to the other one, which is outside. The outside here is DE, to the whole CE. Okay? So our relationship is outside piece to the whole piece equals outside piece times the whole piece. So we're going to use that to our advantage to find an example. So let me put one up. All right, with the magic of editing, the numbers appeared. So we have 9, 6, x, and 5. So how do we do this? Well, we have the outside piece times the whole piece. So the outside piece is just 6 times the whole piece is going to be the sum of this, which is 9 plus 6, 15. Okay? Equals the outside piece, which is 5, times the whole piece. Now look at this. I don't know what the whole piece is, because I can't do 5 plus x. I don't know what that is. So I have to write it as 5 plus x. From there, we're going to do some algebra. Distribute. Simplify this. So this over here is 30, 90. 25 plus 5x. Subtract 25 on both sides. 65 equals 5x. divided by 5 on both sides, x equals 13. So pay attention to the setup. This is algebra stuff. You guys should feel pretty okay with that. This is the important stuff. The setup is the small piece to the whole, the small piece to the whole, okay? So our second rule deals with secants, and that is outside to the whole. I shouldn't say small, I apologize. Outside to the whole, outside to the whole. Sometimes the outside could be longer. So outside whole, all right? I said it 1,000 times already, so hopefully that got into your brain. One more rule. Okay, our last rule. This is the theorem for secants and tangents. So our secants and tangent happening at the same time particularly. Because remember, if it's two tangents, then they're just equal to each other. And we learned that a couple of sections ago. So this one is a secant and a tangent. Tangent, I hope you can see, is the AB. The secant is BD. So let's first talk about the secant. The secant is the same thing. The outside times the whole. So the outside part, which is here, BC, times the whole part, BD. Okay? So outside, whole. Still the same thing with secants. Now, usually we times two things with the proportion, but tangent is only one piece. So what we're going to do is take the tangent and multiply it by itself. When you multiply the same number by itself, it's squared. So we're going to take the tangent squared, okay? So once again, it is the outside times the whole equals the tangent squared. I'm going to do just one example here, but there's many ways how this could turn out, which would cause you to have way different answers. So let's do one. Let's make this, let's make this x. Let's make this, no, let's do this one. Let's do 7, 5, and x. Okay, so let's do that one. So 7, 5, and x. So first off, we're going to do the outside, which is 5, times the whole thing. Should look familiar. 5 plus x. I guess I'm not very creative, it seems like. Equals this over here. AB is squared, so 7 squared. Whatever the length of the tangent is squared. Let's do some simplification. 25 plus 5x, again, distribute the same way as the last question, over 49. Subtract 25 on both sides. 5x equals 24. Divided by 5 on both sides, x equals 24 over 5. We could leave that as a fraction. If you don't, that is the same thing as 4 point... being really blank, 4.8. Okay? But you could leave it as a fraction if you want. All right. So that is our answers. Okay. So that covers up all three rules. Now the thing is, where the x is, will change the question very differently. So we're going to focus on that during the actual homework section, okay? But otherwise, good luck and have a wonderful day.